April 1944, Ypsilanti Township, Michigan. Well past midnight. The air over Willow Run is cold enough to sting the lungs, yet the factory's huge windows glow as if dawn has been trapped indoors. Inside, the sound is not one sound, but a continuous weather system. The clatter of conveyors, the metallic cough of riveting guns, the scrape of wheeled jigs, the steady thump of overhead cranes moving like slow, obedient animals across a ceiling, lost in haze. Somewhere on the floor, a lunch wagon rattles into a bay and stops long enough to hand out something simple and warm, rolls baked by the thousands, before the line pulls everyone forward again. The bomber at the end of the flow does not look like a singular machine built by hand. It looks like an inevitability. In April, Willow Run's crews would produce 453 airplanes in 468 hours, an average rate of one finished B-24 Liberator every 63 minutes. And the factory would do it with the relentless calm of a clock that has learned to build aircraft. That one number, one heavy bomber every 63 minutes, was not merely a boast and not merely propaganda. It was an argument made out of steel, aluminum, labor schedules, and national will. It was the industrial version of a new kind of front line, one that did not run along rivers or ridgelines, but along assembly stations and rail spurs. And it mattered because by 1944, the war had become, as much as anything, a contest of endurance between systems. Which ideology could replace loss with replacement faster than the sky could destroy it? Which government could translate abstract promises into measurable output? Which society could make time itself? Hours, shifts, months, submit. The Willow Run rate did not win the war alone, but it explained why German pilots who lived by tallies and odds began to feel that the arithmetic was turning against them, and why the best of them, aces trained to believe that skill could overcome mass, started to sense that they were being asked to duel a continent. To understand what that realization felt like in the air, it helps to step into the thin, punishing altitude where American heavy bombers lived. Over Europe, U.S. Army Air Force's heavy bombers typically flew at 20,000 to 30,000 feet, high enough to complicate interception and bombing, yet low enough to remain vulnerable to flak and fighters. At 25,000 feet, a crewman, without supplemental oxygen, could pass out in 3 to 5 minutes, followed by death soon after. Cold at those altitudes could reach 50 degrees below 0 Fahrenheit, a temperature that turns exposed skin into a liability and metal into a knife edge. Formation flying was not just a tactical decision, but a survival habit. Tight boxes designed to concentrate defensive fire and keep bomb patterns tight, built out of hundreds of aircraft and thousands of airmen, each vulnerable to collision, icing, and sudden bursts of black flak blooming in the middle of the sky like poisonous flowers. For a Luftwaffe fighter pilot, especially an ace, this was where the war was supposed to be decided. By nerve, gunnery, climbing performance, and timing. German air doctrine, honed in earlier campaigns, had rewarded the skilled hunter, the pilot who could convert seconds into kills. Aces were made in that environment, and they carried with them a powerful expectation that the enemy's machines were finite, that each victory removed something irreplaceable, that a war could be bent by attrition applied with precision. Even when American daylight bombing expanded, it was tempting, humanly, professionally, to believe that no nation could keep sending such formations indefinitely, not over such distances, not under such losses. The German leadership itself had reasons to underestimate. When Roosevelt called in 1940 for American aviation output on a scale that sounded impossible, Hermann Göring laughed and dismissed it as propaganda. No one can build 50,000 planes a year, he said. That's pure propaganda. The dismissal was not only arrogance, it was projection, the assumption that American claims must obey European limits. But the air war over Germany was steadily becoming an encounter not just with bombers, but with the industrial ecosystem that produced them, an ecosystem that could absorb defeats without collapsing, that could replace crews, engines, airframes, and entire groups with a speed that felt, to those under the bombs, unnatural. And that is where the emotional contrast begins. What German soldiers and airmen expected America to be, and what they found it had become. They expected comfort to imply softness, abundance to imply distraction, democracy to imply inefficiency, and consumer culture to imply frivolity. They expected, in other words, that the United States would be rich but slow, capable of impressive prototypes, perhaps, but not of disciplined, standardized output. What they experienced instead was abundance weaponized, a society that treated production as a form of mobilized citizenship, and a factory system that could turn miles of blueprints and tons of raw material into airframes at a rate that made individual victories feel smaller than they had any right to feel. The roots of that change ran backward to a moment before America officially entered the war, when the United States was still wrestling with its own memory of the First World War and its own preference for distance. In the interwar years, America had reduced military strength and allowed parts of the industrial base for war material to atrophy. Yet by 1940, the strategic situation was collapsing at speed. In May 1940, as German forces overran much of Western Europe, Roosevelt called for 50,000 combat aircraft over the next 12 months, a goal that exceeded the total number of planes built in the United States since the Wright brothers' first flight, and at that moment, the country had fewer than 3,000 warplanes, many obsolete. The request sounded like fantasy to critics, but it was also a kind of warning that modern war would not wait for nations to feel ready. Then came the phrase that framed the entire American effort in moral and industrial terms. On December 29, 1940, Roosevelt told the country, "We must be the great arsenal of democracy." It was not poetry for its own sake. It was a directive. Guns, planes, ships, and many other things, he said, have to be built in the factories and the arsenals of America, and the nation would need more ships, more guns, more planes, more of everything. The war, in Roosevelt's telling, would be fought not only by soldiers and sailors, but by workers, managers, engineers, and the machines they operated, by the conversion of peacetime capacity into wartime flow. The challenge was that aircraft were not automobiles. An automobile of the era might have had around 15,000 parts and weighed roughly 3,000 pounds. A B-24 Liberator was a different order of complexity. A huge aircraft, about 67 feet long, described in one account as having roughly 450,000 parts and hundreds of thousands of rivets, weighing about 18 tons. Building it was not like building a car. It was like building a flying structure that could carry war across oceans. Traditional aircraft firms had experience, but not the kind of moving line scale that the emergency demanded. That gap between what was needed and what conventional methods could supply created space for a dangerous experiment, letting an automobile company try to mass-produce heavy bombers. Ford's Willow Run became the most vivid symbol of that experiment. The site, farmland near a creek called Willow Run, was chosen and transformed into an industrial landscape. The main bomber plant, designed by architect Albert Kahn, was enormous, 3.5 million square feet of factory space, with an aircraft assembly line over a mile long. It was thought to be the largest factory under one roof anywhere in the world, and Kahn proclaimed it the most enormous room in the history of man. This was not romantic language. It was an attempt to describe scale that exceeded normal reference points. as if the building belonged to a different civilization than the one that had existed there a few years earlier. The plan itself was born from a clash of cultures. Ford production chief Charles Sorensen, cast Iron Charlie, looked at Consolidated's aircraft building methods and saw what he believed were fatal inefficiencies. Aircraft assembled with labor-intensive procedures, slow fits, and a lack of standardized flow. Sorensen insisted Ford would build the whole plane or nothing, and made the audacious claim that Ford could assemble B-24s at the rate of one each hour. Established aircraft manufacturers, accustomed to far slower rates, considered the claim preposterous. Yet Ford's team broke the bomber into major assemblies and sub-assemblies and designed a build sequence like an automotive program, just on a grander and more complex scale. At first, the promise looked like hubris. Willow Run struggled with design changes, tooling mistakes, labor turnover, housing shortages, commuting difficulties intensified by rationing, and the simple brutality of learning to do precision aircraft work at unprecedented scale. The plant's critics gave it a name that carried both sarcasm and disappointment. Will it run? In 1942, only 56 airplanes were built at Willow Run, a number that could not justify the myth that had been built around the factory. Yet even this failure was part of the transformation. The factory itself became a training ground for mass aviation, and the nation treated those early missteps not as proof of impossibility, but as costs of learning. LeMay was a pragmatist, a commander who valued results over doctrine. He looked at the data and came to a conclusion that shocked his staff. Abandon high-altitude precision bombing in favor of low-altitude area attacks using incendiary weapons. Strip the defensive guns from the bombers to save weight, allowing them to carry more bombs. Fly at night to reduce the effectiveness of fighters and searchlights. Attack from 7,000 feet instead of 30,000, where accuracy would improve and where the bombing would be terrifyingly personal for the populations below. The decision required courage that bordered on recklessness. Low altitude meant the bombers would be vulnerable to anti-aircraft fire from every gun in the Japanese arsenal, including light weapons that could not reach high-altitude targets. Night flying over the ocean meant navigational challenges and the risk of collisions in the darkness. Removing defensive guns meant the bombers could not protect themselves if intercepted. Every element of the plan violated standard doctrine, violated the principles that had governed strategic bombing since the concept was invented. But LeMay had recognized something that Japanese defensive planners had not. The doctrine existed to protect the bombers, and if the bombers could be protected by flying beneath the defensive system rather than above it, then doctrine should be changed. The Japanese had built their defenses to counter high-altitude attack. Their radar systems were optimized for long-range detection of aircraft at altitude. Their fighters were designed to climb quickly to intercept high-flying bombers. Their anti-aircraft guns were positioned and ranged to fire at targets above 20,000 feet. None of these systems worked well against targets at 7,000 feet, arriving at night in a continuous stream that made individual interception nearly impossible. It was an elegant solution, elegant in the way that judo is elegant, using the enemy's strength against him, turning preparation into vulnerability. The Japanese home islands in early 1945 were a study in contrasts. The military command structure remained confident, at least publicly, proclaiming that the divine wind would protect the homeland as it had in 1281 when typhoons destroyed Mongol invasion fleets. Propaganda posters showed heroic civilians preparing to resist invasion with bamboo spears, with determination, with the spirit of Yamato that would overcome material disadvantages through sheer force of will. Radio broadcasts spoke of victories, of successful defensive actions, of American defeats that existed only in the imagination of information officers desperate to maintain morale. But the reality was grimmer. The blockade had tightened throughout 1944, strangling the flow of resources that Japan's war machine required. Oil imports had dropped to nearly zero. Rubber, tin, bauxite, all the raw materials of modern warfare, were sitting in warehouses, in occupied territories, impossible to transport through submarine-infested waters. Food production was declining as fertilizer became scarce, and farm laborers were conscripted into military service. Rice rations in cities had been cut repeatedly. The black market flourished, and those without access to it went hungry. The air defense network reflected this scarcity. Japan had perhaps 1,500 operational fighters dedicated to home defense, a number that sounds substantial until compared to the thousands of aircraft the Americans could field. Worse, the fighters were increasingly flown by inexperienced pilots, teenagers with 50 hours of flight time who had been rushed through abbreviated training programs because veteran pilots were dead, killed in the grinding battles over the Philippines and Okinawa. These boys were told to ram the B-29s if they ran out of ammunition, to sacrifice themselves in kamikaze attacks that might destroy one bomber at the cost of one fighter and one irreplaceable pilot. It was a mathematics of desperation. The radar network was even more compromised. Japanese radar technology had lagged behind German and American development throughout the war, and by 1945, the gap had become unbridgeable. The early warning radars installed along the coast were short-range devices, effective to perhaps 100 kilometers under ideal conditions, prone to failure, easily fooled by weather or by American countermeasures. There was no integrated air defense system, no central command that could track raids in real time and coordinate defensive responses. Each regional command operated independently, often unaware of what neighboring commands were doing, sometimes learning of bombing raids only when the bombs began to fall. This fragmentation meant that when the B-29s approached Tokyo flying low, beneath the effective detection range of coastal radars, there was no warning system capable of tracking them continuously from sea to target. The aircraft appeared on screens intermittently, ghosts that flickered in and out of detection range, their altitude reading as errors that radar operators assumed were equipment malfunctions. By the time visual spotters confirmed that the raid was real and that the bombers were at impossibly low altitude, it was too late to mount an effective defense. Lieutenant Commander Yamamoto had spent the previous 15 months watching Tokyo being transformed from a city into a fortress, though the transformation was more theatrical than substantive. Fire breaks had been cut through residential neighborhoods, creating wide strips of emptiness that were supposed to prevent fires from spreading. Civilians had been trained in firefighting, organized into neighborhood associations that drilled, with buckets and hand pumps, preparing to combat incendiary attacks with equipment that would have been inadequate in the 18th century. Children had been evacuated from the city, sent to rural areas where they might be safer, though this had created its own tragedies as families were separated and young children tried to survive in unfamiliar environments without parents or adequate food. The military preparations were more sophisticated, but no more effective. Anti-aircraft batteries ringed the city, their crews trained to fire predicted barrages at high-altitude targets. Searchlight units practiced coordination with gun crews. The beams meant to illuminate targets for the gunners and to dazzle bomber crews, making accurate aiming difficult. Fighter squadrons stood ready at airfields around the capital, their pilots briefed on intercept procedures, on the importance of protecting the emperor and the government ministries, and the industrial facilities that kept Japan's war effort alive. But all these preparations assumed a certain kind of attack: high altitude, daylight, precision bombing aimed at specific targets. The defensive doctrine was built around making that kind of attack costly enough that the Americans would eventually give up or negotiate a peace that preserved some measure of Japanese sovereignty. No one had seriously contemplated what would happen if the Americans changed the rules, if they arrived at night, at low altitude, with incendiary weapons designed not to destroy factories, but to burn cities. The first incendiary clusters struck eastern Tokyo at 12:08 a.m. on March 10th. Each cluster contained 47 individual bomblets, each bomblet filled with napalm, a jellied gasoline that stuck to whatever it touched and burned at temperatures high enough to melt steel. The clusters separated at altitude, scattering the bomblets across a wide area, ensuring that each bomber could start dozens of individual fires rather than a single large one. The tactical theory was elegant. Start so many fires simultaneously that firefighting resources would be overwhelmed, allowing the small fires to merge into larger ones, creating a conflagration that would generate its own weather system, its own winds, its own terrible logic. The theory worked beyond the darkest expectations of the planners who had conceived it. Tokyo in 1945 was essentially a medieval city, wearing a thin veneer of modernity. The downtown commercial district had concrete buildings, steel-framed structures that could resist fire. But the residential neighborhoods, where millions lived, in density that would have shocked even New York or London, were built almost entirely of wood and paper. Houses were constructed of timber frames with paper screens, designed for a climate where earthquakes were common, and where flexibility was more important than permanence. They were beautiful in their way, elegant expressions of aesthetic principles developed over centuries. They were also perfect fuel. The firestorm that developed over the next 3 hours was a phenomenon that exceeded human experience in its scale and intensity. The fires started individually, small points of light scattered across the dark landscape of eastern Tokyo. But as more bombers arrived, they came in a stream, one every few minutes, each adding its load of incendiaries. To the growing conflagration, the individual fires began to merge. The heat from thousands of burning buildings created powerful updrafts that drew in air from the surroundings, creating winds that grew stronger as the fire grew larger. By 1 a.m., the wind speed at street level in the burning districts exceeded 50 miles per hour, strong enough to knock people off their feet, strong enough to turn embers into projectiles that spread the fire faster than people could flee. A Tiger tank commander who had fought in Normandy and survived to reach the Ardennes wrote in his diary in January 1945, "We are afraid of children with tubes." The sentence is almost pathetic in its simplicity. Children with tubes. Not the Red Army, not the British Eighth Army, not the American Strategic Bomber Force. Children with tubes. But those tubes had killed his comrades, had destroyed tanks that should have been unstoppable, had turned the forests and towns of Belgium into graveyards. For German armor, the fear was rational. The phrasing reflected not cowardice, but exhausted honesty. They were afraid because they had learned that being inside a tank no longer meant being safe, and that knowledge made every meter forward an act of courage that bordered on suicide. In the end, Oberfeldwebel Klaus Müller survived the war. He spent 3 weeks in a field hospital being treated for ruptured eardrums and severe concussion, then was transferred to a prisoner of war camp in England, where he remained until May 1946. He returned to Germany to find his hometown reduced to rubble by Allied bombing, his family scattered, his future uncertain. He never spoke much about the moment when the bazooka hit his tank. When pressed, he would say only that there had been no warning, no time to react, just the explosion, and then darkness. He did not blame the Americans for using such a weapon. He did not consider it unfair or cowardly. It had simply been effective, and in war, effectiveness was the only measure that mattered. Private First Class David Kowalski returned to Pittsburgh in August 1945, 3 months after the war in Europe ended, he went back to work at the homestead, steel works, operating a crane that lifted molten steel from furnace to mold. He married, had children, lived the quiet life he had expected to live before the war interrupted. He did not speak much about Belgium, about the forests, about the moment he had fired a rocket into the side of a German tank and ended the lives of men he had never met and would never know. When his children asked him what he had done in the day war, he said he had been in the infantry, had spent a lot of time being cold, had come home grateful to be alive. It was not a dramatic story, but it was true. The bazooka itself became obsolete within a decade. Tanks developed thicker armor, reactive armor, sloped armor configurations that made shaped charges less effective. The bazooka was replaced by more powerful weapons: the Law, the tow missile, the RPG-7, each generation more lethal than the last. By the 1960s, the original M1A1 bazooka was a museum piece, a relic of a different kind of war. But its legacy endured. It had proven that infantry could fight tanks effectively, that expensive, sophisticated weapons could be defeated by cheap, simple ones, that technological superiority was not an insurmountable advantage. It had shifted the psychological balance of armored warfare, making tank crews aware that they were vulnerable in ways previous generations of tankers had never had to consider. And it had embodied a peculiarly American approach to warfare. Practical, improvised, focused on what worked rather than what was elegant. There is a photograph, taken in Belgium in January 1945, of a destroyed Panzer IV sitting abandoned by the side of a forest road. The snow around it is churned and muddy, marked by the tracks of other vehicles that moved past after the tank was knocked out. The turret is open, the hatches flung back, evidence of a crew that had abandoned the vehicle in haste. There is no visible damage from the outside, no dramatic hole, no charring, no obvious wound. The tank simply sits there, dead, another piece of metal rendered useless by the application of physics and will. The photograph could be of Müller's tank. It could be of any of the hundreds of German tanks knocked out in that winter campaign. The specifics do not matter. What matters is what the image represents. The moment when the hunter realized it had become the hunted, when the fortress revealed itself to be a trap, when the promise of technology gave way to the reality of lethality. War is often described as a clash of wills, of ideologies, of nations. But at its most fundamental level, war is a contest of problem-solving. One side presents a problem, in this case, the tank, mobile and protected and lethal. The other side develops a solution, in this case, the shaped charge warhead delivered by a simple rocket at close range. And then the first side must either adapt to that solution or accept defeat. The German army in 1945 could not adapt. It lacked the resources, the time, the strategic depth to develop effective countermeasures to the bazooka. It could only endure, fighting a losing battle against enemies who had learned to exploit its weaknesses. The men inside the tanks continued to do their duty, continued to advance when ordered, continued to fight until their tanks were destroyed, or their fuel ran out, or they received orders to surrender. But they did so with the knowledge that the advantage had shifted, that the equation had changed, that the outcome was no longer in doubt.